All right, what's up, everybody? If you've made it this far, you're ready to work these practice problems. All right, it's going to give you a little insight, a little information. You're going to solve free, excuse me, you're going to solve free fall problems the same way you would solve kinematic problems. You're going to use the kinematic equations. You're going to set them up, same variables. The only thing that's really going to be different is the fact that when an object falls due to free fall, it's falling with the acceleration due to gravity. So read through the problem. If it's talking about here on Earth, then it's not going to give you that acceleration. You're going to see that in just a second. But if you are on another planet, it may give you the acceleration. That's why it's key for you to know those units. So looking at number one, the first thing I'm going to do before I even start the problem, I'm going to write out my variables. On the kinematic practice problems, you have the little chart to fill in. For free fall problems, you're going to use the same formula, the same variables, but yeah, I'm not giving you the chart. So we have VF, VI, acceleration, time, and delta D. All right, to go in and kind of give you a little bit of information to start with. First things first, this acceleration is equal to G, which is gravity here on Earth, the acceleration due to gravity. And if you remember back in the notes, it is negative 9.8 meters per second squared. All right, now the tricky thing with this right here is the fact that sometimes the negative is important, other times it's not important. I'm going to show you right here why the negative is important, but sometimes you can drop it. On the next practice problem, I think you have to have the negative. So anyway, all right, from there, reading through the question. If a rock is dropped from a building, it takes 18 seconds to reach the ground. How tall is the building? Well, we only given two numbers, 18 seconds. We know the acceleration for gravity. From there, we got to do a little thinking. So if you're standing on top of a building about to drop a rock off, you're holding that rock out over the building, you're holding it still in your hand before you let go of it. So that means that it's going to have an initial velocity of 0 meters per second. From there, it wants to know how tall the building is, which is going to be our delta D. That means velocity final gets the X. Velocity final gets the X. We go to our big four equations. We see that we use equation number 3, okay, which is going to be delta D is equal to VI times time plus 1/2 AT squared, okay? Velocity initial is 0, 0 times the time, 0 times 18 gives us 0. We can mark that out. So we set it up. We have delta D is equal to 1/2 times A. Well, remember, A is equal to G, and G is negative 9.8 meters per second squared, times time, which is 18 seconds squared. Solving all of that out, we get delta D is equal to negative 1587.6 meters. Now here's the issue with this. There's not really an issue. In physics, this makes sense. When somebody who knows physics, studies physics, whatever, when they see that, that just means down. That negative right there means down. So measuring from the top to the bottom, the building or the fall is 1,587.6 meters. You can drop it if you want, okay? But you cannot drop this negative from these practice problems because it will catch up with you. It'll actually mess the problem up, and your goal is to get them all right, okay? All right, from there, moving on to the next practice problem. All right, so for this problem right here, it says a baseball is thrown up vertically with a velocity of 12 meters per second. It's got 3 things it wants you to solve for. Do them in order, okay? So the first one says, what is the maximum height of the baseball? On to the next problem. That's it. First thing I'm going to do, VF, VI, acceleration, time, and delta D. Okay? All right. Looking at this, you're throwing a baseball up in the air. It leaves your hand with a velocity initial of 12 meters per second. You should have learned in the Nearpod that when you throw a ball up, it stops at the top and then it comes right back down. So that means that the velocity final is going to be 0 meters per second. From there, acceleration, which is gravity, which is negative 9.8 meters per second squared. Delta D is what we're solving for. Time gets the x. From there, we use equation big 4, number 4. And it's going to set up as 0 squared, because that is our velocity final, is equal to our velocity initial squared, which is 12 squared, plus 2 times the acceleration, which is 9.8, times delta D. All right, first thing we need to do is simplify this. Remember, 0 squared gives you 0. When you square 12, you're going to get 144 plus 2 times negative 9.8 times delta D equal to 0. From there, subtract 144 over. You end up with negative 144 is equal to 2 times negative 9.8. From there, divide by 2. Divide by 2. 144 divided by 2 is going to be, let me do this in the calculator just to make sure. I think it is 77. No, 72, excuse me. All right, 72 is equal to, don't forget that negative 9.8 delta D times delta D. From there, you need to divide both sides by negative 9.8. And then from there, we get a delta D of 7.34 meters. Now that makes sense. When we divided this negative over to this side, those two negatives canceled out, gave us a positive number as we threw the ball. So right here's me throwing that ball up. It's going up, so therefore, put a head on me. Therefore, the number would be positive. Up is positive, down is negative. Okay, are we good? I'm asking y'all, are we good like you're here? You better be good. All right, moving on to the next one. All right, the next one says, how long did it take to reach maximum height? First thing, VF, VI, acceleration, time, and delta D. All right, from there, going in and filling in all the information. Again, it goes up at the top and it stops, gives us a velocity of 0. Our velocity initial from the original problem said it was 12. Our acceleration is equal to gravity, which is equal to negative 9.8. Our time, that is what we're solving for. And guess what? If we look back at the last problem, we solved for our displacement, 7.34. So we can plug all of that information in. From there, we can use big 4 number 1, comma, big 4 number 2, or big 4 number 3. Now that we have all this information, basically we can use any of the big 4 equations that has time in it. So 1, 2, and 3 all have the variable time in it. I always choose the easiest problems or the easiest formulas. Number 1 and number 2 is the easiest. For this one, I am going with number 2. I like that one the most. So velocity final, 0. Velocity initial is 12 plus acceleration, which is negative 9.8 times time. All right, from there, I'm going to subtract 12 over. It's going to cancel out. It's going to give me negative 12 is equal to negative 9.8 times t. From there, I'm going to divide both sides by 9.8. Divide both sides by 9.8. This is going to give me a time equal to 1.22 seconds. Okay. Again, that canceled out. Those negatives got canceled out. A negative divided by a negative gives you a positive, and for time, you're going to have a positive number. If it was negative, that would imply you going back in time, and we ain't figured out how to do that yet. If you do, hook me up. I want some Disney stock, and what else? Buy me some beach property on like Destin or something like that. Maybe Panama City. No, I want some stuff in Key West. Hook me up. Go down there and get me a beachfront property before it gets big. All right, last but not least, it wants to know what is the velocity when it hits the ground. So basically what we have is we've got Mr. Andrews right here. He threw the ball up. The dots indicate the path. Goes up, stops at the top, comes back down, boom, right before he hits the ground. In these practice problems, even though it's got me throwing it up right here, we're always assuming that the ball is just going to go up, come right back down and stop where it started from. Okay? It's always going to stop where it started from. So going up over here, down over here, velocity up here at the top is 0. And you should have got this from the notes, but as the ball goes up, it constantly slows down. As the ball comes down, it speeds up. If you check the spot at any 2 points in this parabola, the speed is the same. And if you think about a parabola just basically means that it is the same on both sides. Well, given that these objects obey that and follow that parabola, the speed is the same on both sides. One thing we can do with this right here is we can guess on this. What was our initial velocity? It was 12 right there, right? Well, as the object goes up, it comes back down. It should be 12 on this side. The only thing different is it should be negative. And it should be negative because it's going down. Okay, but I'm going to prove this to you mathematically. We're going to go through it. So from there, starting off, we have VF, VI, A, T, and delta D. All right, velocity final, that's what we're solving for. Remember, the velocity initial, draw a line right over here. What did the object do at the top? It stopped. So you break this really into 2 different practice problems. Ball goes up is one problem. Ball goes down is the other problem. So for this one, what was once the final velocity of 0 for this practice problem, the initial velocity is now 0. Okay? Acceleration, same as the last one, is gravity, which is negative 9.8. Time, we had roughly 1.2 seconds. I think I had 1.22. And for there, my delta D, 7.3 seconds. Now, my number does come out a little less than 12, but it's because I've not been following sig fig rules. Sig figs, if you had chemistry, you learned about sig figs. If you didn't have chemistry, don't worry about it. You'll learn about it in college if you go to college. If you don't go to college, you won't ever have to worry about it. But sig figs make sure that you get an accurate calculation, and it's going to show in mine that I don't. All right. So anyway, in this one right here, basically I can use any formula that has velocity final in it, because that's what I'm solving for. So I can use big 4 number 1, number 2, or number 4. Again, if I have my choice, I am going to use big 4 number 2. That is the most simple problem out there. So it's VF is equal to VI. Remember, my VI is 0 plus negative 9.8, my acceleration, times my time, which is 1.2 seconds, or 1.22 seconds. And look, there I go, I wrote the unit. I'm going to drop that, that way it doesn't confuse nobody. Now I carry out my math, I just multiply those 2 together, and I get VF is equal to negative 11.76 meters per second, which is roughly negative 12 meters per second. Good with that? All right. Again, make sure that you are good with this. You're going to break these into 2 separate problems. Your acceleration is always going to be gravity, which is always going to be negative. If you don't like to have a negative number at the end, take the negative off. Sometimes, I mean, it bothers me to think about that. I think negative 12 meters per second, am I slowing down? No, remember, this negative just means that it's a direction. So it's going 12 meters per second down. Other than that, you will be with me tomorrow after seeing this, working some practice problems. So if you have any questions, you can ask me there. All right, I hope this makes sense. If not, find some YouTube videos on it, or just wait till you come to class tomorrow. But anyway, see y'all.